Hello students! Okay, so in today's video, we're going to talk about mutually exclusive events. So based off of the PowerPoint, we know two events are called mutually exclusive if they cannot occur at the same time. So I'm expecting that you have looked through the PowerPoint and know what this word means. From the PowerPoint, we know that if A and B are mutually exclusive, then the probability of A and B, that's going to be equal to 0. Because if they cannot occur at the same time, then they have no intersection. And so to draw a quick diagram for you to see, so very quickly, if this is my event A, and this is my event B, the two events cannot occur at the same time, like what I have right now. So instead, what happens is my two events are like this. They're not occurring at the same time. So they have no intersection. So these are considered mutually exclusive events. This is how it would look like visually. This case right here is where they are not mutually exclusive, so they can happen at the same time. Down here we have a case where they are mutually exclusive, they cannot occur at the same time, so there is no intersection between the two. If two events are mutually exclusive, then the probability of A or B becomes just P of A plus P of B. P of A plus P of B. There will be no intersection because the intersection is essentially 0. And so our formula comes down to P of A or B is equal to P of A plus P of B, and P of A and B is just going to equal 0. So we're going to be using these whenever we deal with mutually exclusive events. So right ahead, we're going to look at this example right here. So suppose a fair 6-sided die is rolled. Let A be the event that the die shows an odd number. Let B be the event that the die shows the number 4. Are A and B mutually exclusive? And so here, we can simply just think this through. You can't be an odd number and be 4 at the same time. So A and B are, yes, mutually exclusive. Because they cannot occur at the same time. Okay, so since we have determined that the two events are mutually exclusive, then what is P of A and B? In other words, what is probability of being odd and 4 when the two events are mutually exclusive? So in this case, just as a reminder, we have the formulas written up here for mutually exclusive events. And I have it listed on the sticky note right here. When two events are mutually exclusive, the intersection is basically 0. So in other words, since these two events are mutually exclusive, then probability of being odd and 4 is essentially 0. And then, since the two events are mutually exclusive, what is the probability of being odd or 4? So based off of our formula over here, let me pull that down a little bit. Based off of our formula, we know that probability of A or B is simply just P of A plus P of B with no intersection. And so that's the same as probability of being odd or 4 is equal to probability of being odd plus probability of being 4 minus 0. So the probability of being odd for a die roll is 3 out of 6. The probability of being 4 for any given die roll is 1 out of 6. Minus 0, that's going to give us 4 out of 6, which reduces down to 2/3. So the probability of being odd or 4 when two events are mutually exclusive is 2/3.